Firstly, I would like to pay my high respect to the professor. My name is Bunlong Prak. I am a student from Computer Science Department, and today I'm going to talk about the linear algebra, Math 241, the Codabar System. In this chapter, I'm going to separate my presentation into 4 parts. The first one is the history. The second one is background. Third, example in the back. The fourth, example with the barcode. First, the history. The inventor of the Codabar system was Hans Peter Lund. He was born on July 1st, 1896, and he died on August 19, 1964. He was a German researcher in the field of computer science and library and information science for the IBM. And he also the creator of the Lund algorithm, KWIC, also known as keywords in the context and indexing, and the Codabar system. The company that created the Codabar system is the IBM, also known as the International Business Machine Corporation. It is an American multinational technology corporation that has the headquarters in the Armonk, New York. The Codabar system is the first used by the IBM company in the 1950s. Here is the logo of the IBM company and its headquarters in the Armonk, New York. The second one is I'm going to talk about the background. The barcode. A barcode is a way that represents a data in the virtual machine readable form. There are 2 types of barcode. The first one is the first dimension barcode, also known as first-D barcode. It is a series of black and white bars that can store information like the product type, size, and color. It can be found on top of the universal product code, also known as the UPCS of a product packaging. It can be used to track packages through packages delivery services provider like the Amazon and the Alibaba company. The second one is the 2-dimension barcode, and it's called 2D. Most people call 2-dimension barcode as a QR code. Its full form is a quick response code, and it is quick to use. You just need a smartphone for scanning. You don't have to find a scanner to scan to see the information. It includes more information than just text, such as price, inventory, label, images, and other information as well, like even video. The Codabar. Every credit card and ATM card is uniquely identified by 16-digit number that represent a 16-digit number, and that represent a check-digit code. The first 15 digits are assigned by the bank issued the cards, whereas the last digit is a check digit determined by the formula that uses the modulo arithmetic. The scanners use this calculation to determine whether the order number were read correctly or not, so that we can chart for the correct product or items. There are two ways of checking the Codabar, the last digit of the Codabar. The first one is using the academic math in linear algebra by applying the check algorithm on each character within the code using the Luen algorithm, also known as the modulo 10. The second one is I found it on the internet. It is much simpler. Even the non-math student or people that have not really advanced in math also able to check the last digit of the number. They are step by step. The first step is to add up all the digits except the last one. The second is start from left to right, add the digit in the odd position. For example, like first, third, fifth, and so on. And then we double that amount and add the total from the step one. The third step is take 10 and subtract the last digit of the last result from the step 2. Now I'm going to show you some example. The first is example in the bank that use academic math operation. Suppose that the first 15 digits of the ATM card are 5, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 4, 2, and the last one is the check digit. Let's X is a matrix of the first 15 digits, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 4, 3, 2, and then D is the last digit. Assume that the check digit is D, and the Codabar system use the check vector C, the matrix that has the sequence of 2, 1, 2, 1, 2, 1, 2, 1, and so on. To increase the odds of error detecting, let's C multiply X and plus H equal to 0. H count the number of the digits in the odd position that are greater than 4. So H equal 4. The odd position that have the value that greater than 4 are 5, and then 5, 7, and then 9. Up next, we have C multiply X plus H. We have the math here. We take 2 from the matrix of C, and then multiply X, which is the 15 digit of the first 15 digit of the card number, and H is the number that has the value that greater than 4. Here 2 multiply plus 4 plus 2 multiply 1 plus 2 plus 2 multiply 3 plus 4 multiply 2 multiply 5 plus 6 plus 2 multiply 7 plus 8 plus 2 multiply 9 plus 0 plus 2 multiply 4 plus 3 plus 2 multiply 2, and plus the last digit is D, and then all of them plus 4, which is H. And after that, we calculate all the number. We have 89 plus D, the check digit, and then plus 4. 8 we calculate the number in the C10 modulo 10. We can say that 89 here concrete on 9 modulo 10, and us to say it as 89 divided by 10 and give the remainder of 9. And then we get the result 9 plus D plus 4. 9 plus 4 is equal to 13. We get 13 plus D. We also need to find the remainder of 13, which is 13 concrete on 3 modulo 10. As say, 13 divided by 10 give the remainder of 3. And then we get the remainder of 3 plus D. So the last digit D for the ATM card must be 7, because we calculated in the modulo 10. As for the result of the calculation is 0 in the C10. The next example is example with the barcode. Determine the last digit of the barcode number. We can do it by the first one is add up all the digits except the last one. It is 8585516600401 except the last digit, and we get the result of 36. And the next step is start from the left to right. Again, add the digit in the out position, like here 588564041 8564041, and we add it up and it is equal to 24. And then we double that amount to it give the result of 48. And then we take the result from here to the result from step 1 is equal 84. And then we take the last digit, we take 10 and subtract the last digit of the result from the step 2, which is 4. 10 minus 4. Here it's a result that match with the check digit. That is it for my presentation. Thank you, teacher, for listening. Thank you.